Hello everyone, happy to see you here. Welcome back to my channel, Hi Mathematics. Today we have a great equation 2 to the power x plus x equal to 3. We need to solve this question for x. So if you have your solution, your answer, you can write your solution in the comments below and then we will check your answer. So let's start. First of all, let's subtract x from both sides. As a result, on the left side we have 2 to the power x equal to 3 minus x. So we just subtract x from both sides. Right now, for better understanding, let's change position. So this expression right on the left side, this one on the right side. We can easily do this. We have equal sign, so it doesn't matter. We have 3 minus x equal to 2 to the power x. So I really hope you understand it. Right now, let's divide both sides by 2 to the power x. So we're gonna divide both sides by 2 to the power x. 2 to the power x is not equal to 0. We can easily do this, and we can divide both sides, our left side and right side, by these 2 to the power x. So let's do this right now. We have 3 minus x. We're going to divide by 2 to the power x. And we're going to divide our right side. 2 to the power x. We're going to divide by 2 to the power x. Right now, on the right side, we can easily cancel these 2 to the x, 2 to the x. We have only 1. On the left side, this 2 to the x, I just want to write in our numerator, okay? But you need to know a really important property. You can easily do this, but you need to change the sign of this power to the opposite one, okay? Because when you have 1 over a to the power b, for example, you need to write it as a to the power minus b if you want to write it in your numerator. So that's why we need to write 2 to the power minus x in our numerator. As a result, we have 3 minus x. I just want to write it in parentheses on the first position, this of expression, and times 2 to the power minus x. So 2 to the power minus x and equal to 1. So I really hope you understand this first step. Division, changing positions, and we have this expression. Right now, for better understanding, I just want to change positions, or I just want to write 3 minus x. I just want to write not like 3 minus x, but minus x plus 3. So it's the same thing. Like for better understanding, I just want to do it. So minus x plus 3. Yeah, minus x plus 3. This is the same thing as 3 minus x. So, yeah, so it changed nothing for us. Yeah, times 2 to the power minus x and equal to 1. Okay, right now I want to multiply both sides by 2 to the power 3. Okay, I just want to multiply both sides by 2 to the power 3. But 2 to the power 3 to cube, I just want to write on this third position. So as a result, what we get? We had minus x plus 3 times 2 to the power minus x and times these 2 cube equal to 1 times 2 cube. So I just multiplied both sides by 2 cubes, so it changed nothing. We have on the left side and on the right side we do absolutely symmetrical same thing. Okay, right now, let's look closely. Let's group these two expressions, 2 to the power minus x and 2 cube. Let's see what we have right here. We have same base, we have multiplication, and we have different powers, yeah? We need to remember, we need to learn from school this identity, a to the power x times another identity, yeah? A to the power y. We multiply in the same expression with same base, but different powers. So as a result, this is equal to a to the power x plus y, yeah? So right now, let's apply this property power rule right here. As a result, the same beginning, minus x plus 3 times 2 to the power minus x plus 3, yeah? Minus x plus 3 equal to, right here we have 8, yeah? 2 cube equal to 8. And right now I want to explain you why I do this, why I multiply both sides, why I divide, why I do this manipulation, because a lot of students might be asking, okay, let's compare what we had in the beginning. We have 2 to the x, 3 minus x. It's like simple expression without any problems, without any fraction, without any negative power. Yeah, but right here we have parentheses, we have negative power, and a lot of students might be asking why I do this, Mr. Why you do this, why you multiply. Okay, and here's my quick answer. There is like a thing which is called the Lambert W function, extremely important, extremely great function in terms of math, yeah? This function looks like that. When you have a times e to the power a, when you have this structure, when you apply Lambert W function to this expression, as a result, this is equal to a. So the main thing, you need to have the same expression right here and the same expression as the power of e. For example, we have 2 times e to the power 2. Everything is great. We can apply Lambert W function because we have the same expression right here and the power of e, and as a result, this is equal to 2. So as you can see, it simplifies that a lot because we can actually get rid of everything of Lambert W function, of e, of a as a power, and as a result we have only our a. And here is the main thing, the key moment. I just wanted to create the same structure on the left side. Yeah, right at this moment we have the same expression right here, and the same expression right here. But the main thing, the main difference, we need to have e. Yeah, right here we don't have e, but when we have e, we can easily apply Lambert W function, which simplifies this expression a lot, because then we can actually get rid of everything. We have only 2, and in our case maybe this is not 2, but we have a really great expression which simplifies us a lot. And here is the main difference. We have minus x plus 3, everything is great. We have minus x plus 3, but we don't have e. How can we get e? We have 2, we don't need 2, we need to have e, because this is our identity. We can't work with 2. This 2 can be written as e to the power natural log 2. According to natural log identity, we can easily express this 2 as e to the power natural log 2. So let's see what will happen. So instead of this 2, I just want to write e to the power natural log 2. So we have minus x plus 3 times e to the power natural log 2, and we're going to raise this to the power minus x plus 3 equal to 8. So I just change nothing. I just write, instead of 2, I just write e to the power natural log 2. But right now, let's look closely at this expression, at this one, okay? How can we simplify it? This is our a to the power x raised to the power y. And we know this identity from school. We know this formula, a to the power x raised to the power y. This is equal to a to the power x times a to the power x times y. Yes, so right now we can write it as minus x plus 3 of the same beginning, minus x plus 3. But right here we can write it e to the power natural log 2 times x plus minus x plus 3. So natural log 2 times minus x plus 3 equal to 8. So I really hope you understand it. But right now let's see. Let's try to fit this structure in our expression on the left side. We have minus x plus 3. We have natural log 2 times minus x plus 3. So this is like a different expression, but we have e. So how can we create this expression? At this moment we have e, but we don't have the same expressions at this place and at this place. In this moment we have the same expression, but we don't have e. At this moment we have e, but don't have the same expression. But how can I do this? It's a very tricky moment. We just multiply both sides by natural log 2, because the main difference about this one and this one, this power, we have natural log 2 times minus x plus 3. At this place we have minus x plus 3. So when we multiply both sides by natural log 2 real quick, then we're going to get the same expression. So we have natural log 2 times minus x plus 3 times e to the power natural log 2 times minus x plus 3 equal to 8. And right now, but 8 natural log 2, don't forget about it. We just need to multiply both sides. Yeah. And right now, let's see what will happen. Natural log 2 minus x plus 3, for example, these are our a. We have natural log 2 minus x plus 3. This is also our a. We have a times e to the power a, so the structure that we really need. Okay, we need this structure. So we can easily, without any doubts, we can easily apply a Lambert W function on our left side. So let's do this. So our Lambert W function of this long expression, natural log 2 times minus x plus 3 times e to the power natural log 2 times minus x plus 3, yeah, equal to Lambert W function. Don't forget about right side, because a lot of students forget about right side. So Lambert W function of a right side, 8 natural log 2. And right now let's look closely. As I said before, we have a times e to the power a, so expression that we really need when we apply Lambert W function, a times e to the power a. Yeah, this is equal to a, but a equal to natural log 2 times minus x plus 3. So on the left side we can actually get rid of everything. We have only natural log 2 times minus x plus 3. Really great. On the right side, what we have? We have Lambert W function of 8 natural log 2. Don't be scared about it. This is like a basic constant. So we have Lambert W function of 8 natural log 2. Right now, let's try to find our x. First of all, let's divide both sides by natural log 2. So let's get closer and closer to this minus x. First of all, let's divide both sides by natural log 2. As a result, on the right side, we have only minus x plus 3 equal to Lambert W function of 8 natural log 2 over natural log 2. We can't cancel it, because this is expression, it works with the Lambert W function, not with the, if we don't have this natural log 2 at this place, we can't cancel it. So I hope you get it, you understand it. Right now let's find our x. How can I do this? It's up to you. How can you express from here x? But x equal to 3 minus Lambert W function of 8 natural log 2 over natural log 2. Right now, a few thoughts about this Lambert W function, because we can simplify this a little bit. First of all, instead of this 8, I just want to write 2 cube. Okay, let's do this. So we have x equal to 3 minus, instead of this 8, I just want to write 2 cube. Okay, Lambert W function of 2 cube times natural log 2 all over natural log 2. I just change nothing, I just express this in a different way as 2 cube. Right now I just want to split it. So 2 cube, I want to write as, so I hope you understand it. So we have 2 cube, I just want to write it as 2 square, 2 square times 2, okay, but 2 times 2 square, so in this way, okay. I just want to express this as 2 times 2 square, so I just want to continue right here at this place. So from here we have x equal to, we have 3 minus Lambert W function of, as I said before, instead of 2 cube, I just want to write 2. On the second position, I just want to leave this natural log 2, and instead of this 2 cube, as I said before, I just want to write 2 times 2 square, so we just need to multiply it by 2 square in the end, okay, and we divide it by natural log 2. So I hope you understand it. I just split this 2 cube, I just express it as 2 times 2 square. Okay, so I really hope you understand it. Right now, this 2 square, I just want to write as e to the power 2 natural log 2. We can easily do this. So as I said before, this from here, yeah, we have right here 2. I just want to write it as e to the power natural log 2. We can easily write this 2 as e to the power natural log 2. But we have 2, so we have, as a result, we need to write it as e to the power 2 natural log 2. Okay, let's do this. So we have x equal to 3 minus Lambert W function of 2 natural log 2 times e to the power 2 natural log 2. So we have e to the power 2 natural log 2 over natural log 2. But as I said before, when we have the same structure, when we have a times e to the power a, and in our case we exactly have that structure, 2 times natural log 2, and we have right here 2 times natural log 2, so we can easily apply it. We already applied this function, so we can simplify it, because we have a times e to the power a, we can actually get rid of everything, we have only our a, but a equal to 2 natural log 2. So from here we have x equal to 3 minus 2 natural log 2 over natural log 2. We can easily cancel this natural log 2, and the final moment, I really like this moment because we have 3 minus 2 equal to 1. So as you can see, all this solution we have 1. So right now we can see a graph, you can see these points of intersection, but in the end, let's check our root real quick. I don't have enough space, so I can check it right here, this line. So we have 2 to the power x plus x equal to 1, and from here, when we check real quick our x equal to 1, we have 2 to the power first plus 1 equal to, we have 3, sorry, in the beginning we have 3, not like 1. Yeah, and 2 to the power first plus 1 equal to 3 is great, so our root is correct. So our answer to this question, our answer, x is equal to 1. This is our answer to this question. So I really hope you understand it. I really hope you learned something new. Right now we can see a graph. You can see this question like from geometric perspective. Is also real great, like to see this question from like different angles, because every time you have like a numerical expression like that, like it doesn't matter, 2 to the power x plus x equal to 3 or different one, you can easily check it from geometric perspective. You can draw real quick a graph, you can see this point of intersection, or at least you can see how many roots you will have, because one point of intersection, it means one root, maybe complex root, but in this way we works with the real number root. So that's why we really need to see this question from geometric perspective, and few really important hints, because you know a lot of students might be thinking that we can easily solve this question by inspection, 2 to the power x plus x equal to 3. This is not that hard, like to check real quick the basic ones, like 0, 1, 2, 3, minus 1, minus 2, like few roots, and then they can easily say that we can solve this question like that with inspection method. But this is not the best way to solve this question. Inspection method is a great method when you want to prove your root, when you need to check your root real quick in the end. But before this, you need to use a method which is called like solution. You need to solve this, you need to draw a graph, you need to solve this question completely with all your knowledge, with all your algebra knowledge. Because as you can see right here, solution is sometimes is a complicated thing, but when you solve this question correctly, when you prove this root with inspection method, it works perfectly for you and for your teacher. Yeah, this combo, this mix works perfect. The solution with the inspection method, with the proof, it works absolutely great. So I really hope you enjoyed this solution. I really hope you understand it. I did my best. I try my best to to explain you step by step, like with all of these properties on the right side. I really hope you'll learn a little bit. I really hope you'll learn something new. I really hope you'll learn Lambert W function. I think that you know each of this property, each of this rule, and if you do, it's really great. You can easily be proud of yourself that you know a little bit about math. So thank you for your time. Take care of yourself. Have a great day. Also write your thoughts, write your response in the comment below. Let's see, let's exchange information. Let's see what do they think about these type of questions. What do you think about this solution? It's also really great to see you respond. Yeah. So thank you for your time. Take care of yourself. Have a great day. See you in the next videos.